Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over properties of exponents. We're going to be focusing on how to multiply monomial exponents using the product property of exponents. This standard is covered in Algebra 1, Algebra 2, and Pre-Calculus courses. Don't forget there are 17 practice problems at the end of this presentation that we'd like you to try out just to demonstrate mastery of the content covered in this video. If you'd like to gain access to the entire playlist, the course, and other valuable resources, you can visit our website at mathgotserved.com or just take a look at the link in the description below. To get us started, we're going to take a look at the formula that's going to guide our problem solving process. So the formulas that we are going to be looking at are as follows. These are the product property of exponents. So if you have x to the a multiplied by x to the b, basically you're multiplying two exponents with the same base. The rule is you add the exponents, okay? X to the a plus b. And then if you have coefficients, let's say a x to the a times b x to the b, you have two exponents with the same base, but they have coefficients. What you do is you multiply the coefficients, so a times b, and you add the power of the exponents that have the same base. All right, so these are the formulas we're going to be doing. So instructions are as follows. We are to simplify the following. Number one, what if we have x raised to the third power times x raised to the fifth power? Okay, let's go ahead and take a look at this. So if we want to do this, we're going to be applying the product property of exponents, x to the third times x to the fifth. Since we have two exponents with the same base, this is simply going to be x to the, you add the powers, okay? 3 plus 5, and your final answer will be x to the 8th power as the answer to question number 1. All right, let's take a look at question 2. So question 2, what if you have, let's see, question 2, we have a times a to the 7th power. Okay, all right, so how do we apply the product property of exponents in simplifying this product right here? If you notice, the second factor has a power of 7, but the first factor doesn't have a power. So what are we going to add this to the 7? Okay. Now, whenever you don't have a power, every term that doesn't have a power has an invisible power. And that invisible power is 1. Okay, so every term has a power. If it's not specified, the default or implied power is 1. Okay, so this a that doesn't have a power actually has a power, which is 1, the invisible power. And that's what we're multiplying by a to the 7th, okay? All right, so if we apply the product property of exponents, this is going to be a to the 1 plus 7. And the final answer is going to be a raised to the 8th power. And that's the answer to question number 2. All right, let's take a look at question 3. So for question 3, what if we're to find 3x, the quantity 3x squared times the quantity 5x raised to the third power? Okay, what if we were to do that? Now to do this, let's see, we have 3x squared times 5x to the third. All right, so all we're doing here is just multiplying two monomials. All right, so we can rewrite this as 3 times x squared times 5x to the third. All right, we're just simply multiplying two monomials. All right, so to multiply this out, we're going to multiply the coefficients. 3 times 5. Okay, when you multiply 3 times 5, you get 15. And then we're going to apply the product property of exponents in multiplying x squared times x to the third, which is x to the 2 plus 3. Okay, and then our final answer is going to be 15x raised to the 5th power. All right, so there goes the answer to question number 3. All right, let's take a look at question 4. For question 4, what if we were to simplify the following? If we have the product of the quantity 4x squared times 2x, the quantity 2x to the 5th power. All right, so how do we multiply that? This is very similar to question number 3. So we have 4x squared times 2x to the 5th. Since we're multiplying two monomials, we can just drop the parentheses. So we have 4x squared be multiplied by 2x to the 5th power. All right, so if we apply the product property of exponents with coefficients, you multiply the coefficients. Basically 4 will be multiplied by 2, so 4 times 2, that goes together. And then the two exponents with the same base, we add those. All right, that's how it works. And then we have 4 times 2 is 8x to the 7th power. And that's the answer to question number 4. All right, let's take a look at number 5. So for question 5, what if we are to simplify the product 7x to the 4th times 3x squared? Let's do that. Ladies and gentlemen, number 5 is similar to number 4 and number 3. Okay, you don't have parentheses there, but it's a product anyway. So it's exactly the same procedure we're going to be applying there. 7x to the 4th times 3x squared. We are multiplying two monomials. Okay, so the 7 and the 3 will multiply the coefficients. 7 times 3. And then for the exponents with the same base, we're going to do what? Add the powers, 4 plus 2. Okay, so our final answer is going to be 21x raised to the 6th power. And that's the answer for question 5. Okay, let's take a look at number 6. So for question 6, what if we are to multiply these two monomials with two variables, 6ab to the 4th times the quantity 5a squared b to the 3rd. All right, let's go ahead and do this. All right, so we have 6ab to the 4th, that quantity, times 5a squared b to the 3rd. Since we are multiplying two monomials, we can just drop the parentheses, right? So it's going to become 6ab to the 4th times 5a squared b to the 3rd. Okay, so we're going to multiply the coefficients first. So 6 and 5 are the coefficients of the two monomials, the constant terms. 6 times 5, let's write it down, 6 multiplied by 5. And then for the a's, we're going to use the product property of exponents, likewise the b's. Now for the a's, this a right here doesn't have a power, so what power does it have? Remember, we talked about this in number 2. The power is the invisible power, which is 1. Okay? All right, so for the a's, we have a raised to the 1 plus 2. And then for the b's, remember when you're multiplying exponents with the same base, you add the powers, b raised to the 4 plus 3. Okay, so if we simplify this, 6 times 5 is 30. It's going to be 30a raised to the 3rd power, b raised to the 7th power. And that's the answer to question number 6. All right, let's take a look at number 7, something similar to number 6. So for question 7, what if we were to simplify 9, the quantity 9x to the 7th power, y squared, times the quantity negative 2x to the 3rd power, y raised to the 5th power. All right, let's go ahead and do this. All right, so we're multiplying two monomials. All right. So what we're going to do here is just basically express this as a product of two monomials. We can drop the parentheses. Okay, so it becomes 9x to the 7th y squared times negative 2x to the 3rd y to the 5th. Okay. All right, so we'll multiply the coefficients. 9 times negative 2. And then exponents with the same base, what do? We add the powers. X raised to the 7 plus 3, and then y raised to the 2 plus 5. Okay? All right, let's simplify. What is 9 times negative 2? That's negative 18. X to the 7 plus 3, that's 10. And then y to the 2 plus 5, and that's 7. The answer to number 7 is negative 18x to the 10 y to the 7th power. All right. Okay, let's go ahead and take a look at the next one. Question number 8. Let's say you're to simplify 3y times negative 4y to the 3rd times 5y to the 6th. Let's write that again, 5y to the 6th. All right, ladies and gentlemen, in this problem, we are multiplying three monomials, three exponents. So how do we attack a problem like this? Well, we'll follow exactly the same procedure that we have followed in previous problems. Okay, so we're going to multiply the coefficients and then apply the product property of exponents in multiplying the exponent component. Alrighty, let's do it. So for this particular problem, we're going to multiply the three coefficients, 3, negative 4, and 5. So when we multiply those, we're going to have 3 times negative 4 times 5. That's the coefficient component. And then the y's will add all the powers. Okay, this has no power, so it has an invisible exponent, which is 1. Okay, so for the y, we're going to have y raised to the 1 plus 3 plus 6. Okay, let's go ahead and simplify that. 3 times 4 is 12. 12 times 5 is 60. So we have a negative there, so it's negative 60 y raised to the 10th power. And that's the answer to question number 8. Alrighty, let's take a look at question number 9. So for question 9, let's say we were multiplying quantity negative 3xy times quantity x squared y times quantity 4x y to the 7th. Okay? Alright, let's go ahead and do that. Now, this problem that we're working on is exactly the same thing as question number 8. We are multiplying three monomial terms. All right, so what does that mean? Well, as we've done in previous problems presented in this format, we're simply going to drop the parentheses, okay? Let me put up a line here so we don't get this confused. So we're going to basically drop the parentheses. Alrighty, so if we do that, we'll have negative 3xy multiplied by x squared y multiplied by 4xy to the 7th. Alrighty, so using the property of exponents we talked about earlier, we are going to proceed to multiply the coefficients first. So negative 3 and 4. The middle term has a coefficient of 1. It's the multiplicative identity, so we don't have to write it down. So we have negative 3 times 4. And then we're now going to apply the product property of exponents to the variable terms. Let's specify the power of the variable terms without power. So x doesn't have a power, so it has an invisible power of 1. This y here has a power of 1. This y here has a power of 1. And this x has a power of 1. Okay? All right, so applying the product property of exponents, we have x. For x, we have 1, 2, 1. So it's going to be 1 plus 2 plus 1. Okay? And then for the y, we have 1, 1, 7. So it's 1 plus 1 plus 7. So remember the product property of exponents. You add the powers when multiplying exponents with the same base. Okay, so 3 times 4 is 12, so we have negative 12x to the 1 plus 2 is 3. 3 plus 1 is 4. So x to the 4th. And then for the y, 1 plus 1 is 2. 2 plus 7 is 9. The answer to question number 9 is negative 12x to the 4th, y to the 9th power. All right, let's take a look at question number 10. So for question 10, what if we have the following situation? Question 10, we are to simplify the product of the following monomials. Let's say we have 5, the quantity 5m, times 3m raised to the 6th power n square, n to the 2nd power, multiplied by n raised to the 5th power. Okay. All right, let's go ahead and do it. So for this problem, we're going to follow the same procedure that we used for 8 and 9. This is just a product of 3 monomials. So we can just drop the parentheses, okay? So we have 5m times 3m 6n squared n to the 5th. You can just drop the parentheses, okay? When you multiply monomials, it's 5m times 3m to the 6th n squared times n to the 5th power. Alrighty, now we are in a position to apply the product property of exponents. We're going to multiply the coefficients first. So the coefficients that we have are 5 and 3. 5 times 3 is 15, so we have 15. And then let's specify powers for terms that do not have powers. So just m doesn't have a power, so it has the invisible power of 1. Okay, so we have 15m raised to the 1 plus 6. That's the product of this m and this m right here. And then for the n's, we have n to the 2 for n squared plus 5 for the 5 from the last factor. Okay. All right, so there you have it. And then our final answer is going to be 15 m raised to the 7th power n raised to the 7th power. All right, that goes the answer to question number 10. Alrighty, let's take a look at question number 11. Okay, so for question 11, let's say we are to find the product of 9c squared d raised to the 2nd power, so 9c squared d squared times 7c to the 4th d. Alrighty, so let's go ahead and do this one. Alright, so we're multiplying 9c squared d squared by 7c to the 4th d. Alright, so what we're going to do first, we're going to basically apply the product property of exponents. Let's identify our coefficients. They are 9 and 7. So let's multiply those two. We're going to have the product of 9 and 7. So 9 times 7. And then with the variables, we have c raised to the 2 plus 4. And then d raised to the 2 plus what? This d doesn't have a power, right? So it has invisible power, which is 1. So it's d raised to the 2 plus 1. Okay? And then we're going to go ahead and simplify that. Our final answer will be 9 times 7, which is 63. C to the 6th power. D to the 3rd power. All right? So there goes the answer to question number 12. I'm sorry, question number 11. All right, let's move on to question number 12. So for question 12, let's say we have to multiply negative 3 by the quantity r to the third s times the quantity negative 6r square s to the sixth. Okay, let's go ahead and do that. All right, so first and foremost, let's rewrite the problem. We have negative 3 times r to the third s times negative 6 r squared s to the sixth. Now, to multiply these out, we are simply going to drop the parentheses since we're multiplying three monomials. All right, so negative 3 is being multiplied by r to the third s times negative 6 r to the second power s to the sixth power. All right, so that's what we're dealing with here. Okay, so we're going to apply the product property of exponents when multiplying these monomials. Multiply the coefficients first. Coefficients here are negative 3 and negative 6. So those two will be multiplied with each other. So negative 3 times negative 6. And then we have r. We add the powers. R's exponent to the same base being multiplied. You add the power r to the 3 plus 2. And then s to the first s has the invisible power of 1. So s to the 1 plus 6. Okay. And then our final answer is going to be negative 3 times negative 6 is positive 18. 18r to the fifth power s to the seventh power. Okay, so there goes the answer to question number 12. All right, let's take a look at number 13. How about we throw in some fractions into the mix? How can we apply the product property of exponents when fractional coefficients are present? Number 13, what if we have negative 9a to the fifth power b be multiplied by 1/3 a to the third power b to the fifth power. All right, so let's take a look at how to do this problem involving fractions. The solution is as follows. Let's write the problem with quantity negative 9a to the fifth b times 1/3 a to the third b to the fifth. Now, since we're multiplying two monomials, we can drop the parentheses. So we have negative 9a to the fifth b be multiplied by 1/3 a to the third b to the fifth. Okay, so let's go ahead and multiply coefficients. So we're going to be multiplying the integer negative 9 with a rational 1/3. So we have negative 9 times 1/3. Okay, and then for the variable components, exponents with the same base, you add the powers, a to the 5 plus 3. And then b, the first b doesn't have a power, so it has the invisible power of 1. B to the 1 plus 5. Alrighty, so this becomes negative 9/3. You can put this 9/1 and multiply and reduce, or reduce then multiply. Let's multiply and reduce, okay? So 9 times 1 is 9. 1 times 3 is 3. So negative 9/3. A to the 5 plus 3 is 8. B to the 1 plus 5 is 6. Alrighty. So what is negative 9 divided by 3? You can divide top and bottom by 3, okay? So you just reduce that fraction since they have a common factor of 3. So divide the top and the bottom by 3. So you have negative 3. A to the 8th power, b to the 6th power. And there goes the answer to question number 13. All right, let's move on to 14. Let's take a look at another product of monomials involving fractional coefficients. For number 14, what if we were to simplify 10y and be multiplied by the quantity 5/2 x square y to the third. Let's say we're dealing with something like this. So how do we go about doing that? All right, so as follows. So we're multiplying 10y by this quantity right here. So we can just drop the parentheses. Okay, so this is basically 10y being multiplied by 5 over 2 x squared y to the third. Okay, so in multiplying, we're going to start off by multiplying coefficients. So 10 and 5 over 2 are the coefficients we're going to be multiplying. So we have the quantity 10 times 5 over 2. And then we have x squared stays alone. There isn't any x squared in the first factor that we're multiplying by. But for the y's, we have y to the invisible power of 1 multiplied by y to the third. So applying the product property of exponents, we're going to have y to the 1 plus 3. Alrighty. So in this product here, we can multiply and reduce, or reduce and multiply. In problem 13, we multiplied and reduced. Let me show you how to reduce and then multiply, okay? So notice that 2 and 10 have a common factor of what? What is the biggest number that can go into these two evenly? 2. So you can divide 2 by 1, divide 2 by itself, so 2 goes into 2 one time, and then you cross reduce, divide this 10 here by 5. Okay, when reducing, you can divide out factors from a denominator and a numerator position, as long as they're common. Okay, all right, so now we have reduced. There's a 1 here. We can now multiply. Okay, so 5 times 5 is what? 25. Bam, there you have it. And then x to the second power, y raised to the 1 plus 3, which is 4. Okay, if you don't like reducing and then multiplying, you can just multiply and reduce. So if we want to use that approach here, would have multiplied the top to get 50 divided by 2 to get 25, and it's the same thing. All right, so there goes the answer to question number 14. All right, let's move on to the next one. Let's say we have to find the product of 1/6 times the quantity 12m to the fourth n times negative 2m to the fifth n to the fifth. Let's do that. All right, so how are we going to do this one right here? Let's rewrite the problem. So we have 1/6 times 12m to the fourth n times negative 2m to the fifth n to the fifth. All right, so to get us started, let's just rewrite this. We don't have to put the parentheses since we're multiplying monomials. Okay, so it's 1/6 times 12m to the fourth n times negative 2m to the fifth n. Remember, when you're just multiplying monomials, you can drop the parentheses, okay? But if you have binomials, you have to distribute and all that stuff, but we don't have to do that here. Okay, so applying the product property of exponents, we are going to multiply the coefficients first. So 1/6 times 12 times negative 2. If we multiply all those together, we have 1 over 6 times, we can write 12 as a fraction, 12 over 1 times negative 2 over 1, okay? And then now, for the m's, you have m raised to the, remember when multiplying exponents of the same base, you add the powers. M raised to the 4 plus 5, n raised to the, this n has no power, so we give it the invisible power, which is 1. So it'll be n raised to the 1 plus 5. Okay? All right, so here what do we have? We can reduce and multiply, or multiply and reduce, the same thing. So let's try multiplying and reducing here, okay? So 1 times 12 times negative 2 is negative 24. So we have negative 24 over 6 times 1 is just 6. M raised to the 9th power, n raised to the 6th power. Okay? We can simplify further. The greatest common factor of 24 and 6 is 6. So we divide top and bottom by 6. Divide out that common factor, and then that's going to leave us with negative 4 m to the 9th power n to the 6th power. Alrighty, so there goes the answer to question question number 15. All right, let's take a look at question 16. So for 16, let's say we have the following situation. Number 16, what if we have 3x to the 7th power y times 2x y to the 5th plus x to the 4th y to the 4th times 4x to the 4th y square. Okay, let's go ahead and do this. So I'm going to rewrite the problem. We have 3x to the 7y, 2xy to the 5th, plus x to the 4th, y to the 4th, 4x to the 4th, y square. All right, so following order of operations. To simplify this, we're going to multiply first and then add after that. Okay, just following, please excuse my dear Aunt Sally. So let's carry out the product of these two products here, this product of these monomials, and then we find the sum of the product. Okay, if possible, okay, we just look at the degrees of the variables and see if they're the same. All right, so what do we have? On the left side, we have so this is just a product of 3x to the 7th y times 2xy to the 5th. Same applies here. This is just x to the 4th y to the 4th times 4x to the 4th y square. All right, so for the first product, 3 times 2 is 6. X to the 7, this has a power of 1, so 7 plus 1, that's 8. And then the y has an invisible power of 1, so y to the 1 plus 5, and that's 6. Bam. All right, and then over here, this one just has a 1, right? It's a visible 1 here. 1 times 4 is 4, so we have 4 raised to the, 4 times x raised to the 4 plus 4 is 8. And then for the y, 4 plus 2 is 6. Now, if you take a look at these two monomials, they are like terms. Remember in our previous video, we talked about how to combine like terms. Well, you look at the coefficient, they have coefficients about rationals, and then the powers of, we have identical variables and their powers are the same. So they are like terms, so we can combine. Okay, so all we just do is combine the coefficients. 6 plus 4 is 10, and then we bring down the variable component, 10x to the 8th, y to the 6th power, and that is the answer to question number 16. All right, so let's take a look at one more problem. Number 17. If you've lasted this long, you're doing an excellent job. So one more, and then you have some practice problems to demonstrate that you've mastered what we've been talking about in the past 30 minutes or so. All right, so question 7, what if you have, 17, you have 6, you have to simplify 6a to the 5th, b to the 3rd times 9a to the 5th, b square, plus a to the 4th, b, times negative 2a to the 6th, b to the 4th. All right, what if you were to simplify that? Let's do it. So for this one, let's write the problem. We have 6a to the 5th, b to the 3rd, times 9a to the 5th, b square, plus a to the 4th, b, times negative 2a to the 6th, b to the 4th. All right, so first things first, since we're multiplying monomials, on the left side and the right side of this plus sign, we can just drop the parentheses. This is 6a to the 5th, b to the 3rd, times 9a to the 5th, b square, plus, and then here we can drop the parentheses, a to the 4th, b, times negative 2a to the 6th, b to the 4th. Now, following order of operations and simplifying this expression, we are going to multiply first before we add, if possible. If they're like terms, then we can add. Okay. All right. So what we have on the left's product, we have 6 times 9. That's 54. For the a's, it's a to the 5 plus 5, which is 10. And then for the b's, b to the 3 plus 2 is 5. Okay, plus the product to the right. We have a -2 there, so that's going to change this sign from a positive to a negative, because plus times minus is a product of different signs, which is always minus. Okay, -2, a to the, you add 4 plus 6, which is 10, and then this b has a power of 1 right here, so b to the 1 times b to the 4th, you add the powers, b to the 5th power. Okay, all right, and then we can go ahead and combine these two. We're gonna have we're gonna have 54 so these are like terms, as we can see. The coefficients are both rationals, which are combinable, and then the variables are the same, and the powers of the variables are identical. So we have like terms here. Okay, so to simplify this, you just simply subtract the coefficients. 54 minus 4 is 54 minus 2 is 52, and you bring down the variable component a to the 10, b to the 5th. All right, so there goes the answer to question number 17. Alrighty, excellent job paying attention to this presentation. Now it's your turn to demonstrate mastery by attempting the following 17 problems. What I'd like you to do, go ahead and try out these 17 practice problems. What you're going to do is pause this video presentation at this time, copy down these problems, work on them, and when you're done, click on the playback button, and then we're going to display what the answers are. Alrighty, hopefully you had a chance to try out the problems. Let's take a look at what the answers are. So question for number 1, the answer is x to the 6th power. For number 2 is a to the 6th. For number 3 is 10x to the 5th power. For number 4, it's 18, x to the 11th power. For number 5, it's 20x to the 8th power. For number 6, it's -16, a to the 7th, b to the 7th power. For number 7, it's -21, x to the 5th power, y to the 10th power. The answer to number 8 is -48, -48 y to the 9th power. For number 9, the answer is -14 x to the 8th power, y to the 10th power. For number 10, the answer is 20m to the 6th power, n to the 7th power. For number 11, the answer is 60c to the 6th power, d to the 7th power. And then for number 12, the answer is +10 r to the 4th power, s to the 6th power. For number 13, the answer is -4 a to the 5th power, b to the 4th power. Okay, that's the 3 right there, just to make sure. So this was b to the 3rd. All right, and then for number 14, our answer is 12x y to the 4th power. Number 15 is -15 m to the 5th power, n to the 8th power. And for number 16, the answer is 15 x to the 7th power, y to the 4th power. And the last one, number 17, The answer is 31, a to the 5th power, b to the 8th power. All right. So how well did you do in this practice problems? Let us know in the comment section below. If you have any questions or any clarifications that you would like us to make, just specify it in the comment section below, and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. If the contents were helpful and your studies of exponents, to give us a thumbs up or a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other cool presentations such as this. We upload videos to our page on a regular basis, so don't forget to subscribe. Questions and comments, just include them in the comment section below and we'll be more than glad to respond. Don't forget to check out the links in the description and also visit our website, Mathgotserved.com, for a wide variety of resources to help you in your study of exponents. Thanks again for watching and have a wonderful day. Goodbye.